We all know, with the increasing greenhouse gases, the Earth's climate is changing. Primarily, the temperature is getting warmer, and also we experience more extreme events like floods or even extreme droughts. And in Hong Kong, we experience a lot of typhoons. So my research wants to understand what drives those extreme events and how we can make better predictions. And when we move into this warming climate, what strategies we can take to mitigate and also adapt to this changing climate. I'm Hui Su. I am a STEM professor at the Hong Kong University of Science and Technology. I study climate change and extreme weather using observational data, numerical models. So I analyze data from satellite observations and also from some surface observations, and we use numerical models to study the weather phenomena and also longer term variability such as climate change and what drives the climate change prediction uncertainties. So meaning I focused on studying clouds and so how clouds impacts our prediction of future warming. I led a group of students actually to work on launch our own satellite. So this actually happened last month. We actually were able to launch a satellite of our own, actually that measures the global surface, like land surface, ocean surface, and also the atmosphere. So basically using very high resolution images, we can identify hazard conditions, for example, landslide, flood, wildfires, because you will see the images from satellite differ from normal conditions. So this is actually kind of very ambitious project from the beginning. I didn't think it was possible, but in Hong Kong, we are very fortunate to have support from our university and also from very generous donors. So we were able to put together a plan within a few months and working with commercial satellite companies. So we launched our satellite on 25th of August. And now the images came back and looks very nice. So for example, last week, Hong Kong experienced a super typhoon and there were flooding in the city. So from satellite images, so we will be able to identify exactly the extent of the hurricane, like the tropic cyclone's economic damages. So that's also, I think it's an innovative way to actually assess the damages from natural hazard. Normally, you probably send people to the field and do some investigations, but now using the remote sensing techniques from satellites like 500 kilometers above the surface, we can see the ground very clearly, and we can identify the areas that were affected by the super typhoon very quantitatively. So this is also owing to this advancement in technology. So we now can do research, not just on the ground. We use satellites to do our research. So we have the satellite flying. So we are start to receive a lot of data. So I will have my team working on analyzing the data and just really derive a lot of information so we can actually give that information to our government agencies and to our public. So I think it's really a kind of a new way to do research. 2 years ago, my team published a paper to build using the machine learning techniques. We built a model to predict the rapid intensification of tropic cyclones. So basically, when tropic cyclones kind of moving across the ocean, we want to find out what factors drives its intensity change. And this has been a forecast challenge. So we use some existing data, and based on historical storms, we built this machine learning model. So that can be used to predict the hurricanes, the typhoons intensity change. So it turned out our model, based on the machine learning, outperformed the National Hurricane Center's operational model. So it was quite a success. And the Hurricane Center now is thinking to also moving into using machine learning to predict tropic cyclone intensity change. This work was partly motivated by some conversations with data scientists from IBM. So they actually have been working with the massive data and use the modern technologies like machine learning, AI, to do some predictions or like analysis of the data. So traditionally in the meteorological field, we use the statistical approach or numerical models to do the tropic cyclone forecast. But for rapid intensification, that means the storm's speed changed very suddenly. So it has been a difficult problem for the forecast centers. But when we talk to the IBM scientists, data scientists, they say, oh, we have this new like Watson Studio tools. Maybe you guys can try and see how it can affect your forecast scale. So it's really just through this very interdiscipline kind of interactions, then we start to work with them and use our data, but use their machinery. It turned out a very fruitful collaboration. So now the IBM scientists are still seeking new ways to collaborate with like a meteorologist or climate scientist to use those modern techniques to do some social good. So like in my field for meteorology, climate science, math is really a fundamental skill because we need to know the physics, like governing the motion of air and the changes of the climate in this complex system. But the math is not really just the formulas, equations. There are already set rules how you solve problems. A lot of times you need to actually break the discipline boundaries, like talking to computer scientists, data scientists, also sometimes maybe even people working on humanity, like arts, because there are a lot of kind of ingredients in the science research. You need creative thinking. So for example, actually when I worked at the NASA, we always work on mission formulation to design our instrument to solve some particular science problem. We actually work with artists because we want to illustrate our thinkings in very kind of explainable ways to ordinary people, because we also want to convince our sponsors, convince our public, like the work we do is important. And then to convey that idea clearly, also we need actually artists to make good illustrations how we describe the process we want to tackle. So in fact, in that like interaction, I found the artist creativity really helped because they can convert our sometimes very abstract thinkings into nice visualization. So that makes the idea very easy to be understood, and also to spark some new thoughts, actually maybe find the missing links and connect dots. So in fact, I think the science research is very interdisciplinary and it needs a lot of innovation and creativity Each paper, it needs to have this innovation, creativity in it. So when I talk to my students, I feel young people generally are very kind of unconstrained in some way, because if you are a trained scientist, you tend to follow certain kind of routines, or there are kind of recognized, established methods you can follow. But for people who have relative less training, so they come in with fresh ideas, sometimes very out of box thinkings. So that's very helpful. So I think the conversation with my students and postdocs turned out always being very fruitful. As a scientific research, innovation, creativity is valued the most, because we always build on previous people's previous work, but we need to add new flavors to it, and we need to think creatively, and to come up with new method or sometimes new topics in our field, because we always want to push the boundaries and find cutting edge questions and drive and solve the leading challenges in our field. So creativity is just the most important quality we need in the science research.